Okay, this video is going to walk you through the practical use of SPSS to conduct logistical regression analysis. And you're going to, I suggest 3 things to prepare you for this analysis assignment number 4. First of all, read through the learning guide, which is posted under the assignment number 4 tab in your Canvas shell. Open up and have at your disposal the how-to guide, which has screenshots and a cookbook step-by-step description of how you're going to conduct the analysis. And then open up the data set. And as you look at the data set, this should be it, substance abuse data. It's in the Canvas shell under the assignment. And this is all the practice assignment to get you ready for the analysis and interpretation number 4, logistic regression, that you'll turn in for a grade. So you're going to start with going up to your toolbar here, click on Analyze, go to Regression, and do binary logistic regression. And that is when you have dichotomous variables. So the dependent variable of interest in this particular assignment is looking at the abstinence 6 months after treatment. So you're going to enter abstinence or the abstain as your dependent variable. We are interested in trying to predict abstinence by adding some additional variables, and that will predict the abstinence from these predictor variables. And SPSS calls those predictor variables covariates. So we're going to add the ones that we think might predict who will abstain and who will not. So the first one we're going to add is education. And that's a continuous variable, so it's fine the way it is there. Employment status, you're going to add that one. You're going to also add the outpatient status as a variable. The discharge status, and whether or not the person's participating in Alcoholics Anonymous, and whether or not they went to aftercare. So those are your predictor variables. Now you will notice that SPSS recognized both participation in AA and aftercare as categorical variables. There's actually a couple more that it should have recognized as categorical, but it did not. But because we have categorical variables, we want to click this categorical tab here. And so it recognized AA and aftercare as categorical variables, but we need to add some additional categorical variables. We are going to add the employment status and the discharge status as categorical variables, and then click Continue. You are also going to leave this method as the enter. For now, that is going to take all of these covariates or predictors in the analysis at once. So click OK, and you should get a printout that looks like this. This tells you how many cases were in your total, so you can see there were 80, and how many were included in your analysis, and the number of cases with missing data. This part tells you the dependent variable coding, and it also tells you which categorical variables were coded in this data. As you go down here, we'll look first at the block 0. So block 0 tells you how well you can predict the dependent variable, the abstain, with no predictors in the model at all. So in this example, it's 68.2% is your correct prediction without adding any of the covariates. So the fact that this person was in treatment alone predicts that 68.2% will abstain without any of those other predictors at all. This table tells you how many variables were in the equation, and there were none. And then it also tells you that this is a significant p-value that tells you that the model works better than by chance. This table tells you how many variables were not in the equation. So now let's go on and put the variables in the equation and see what happens. When you use the enter method, it puts all the variables into the model at once. And so that's what we have here for the enter method, all the variables at once. This step significant p-value of 0.006 suggests that all the variables provide a good prediction. In this case, that chi-square statistic tells us that the model is a good fit for the data. Next, we can look at the R-squared here, and you can see that that's 0.405, and that tells us the percentage of the variability in the dependent variable that is accounted for by the predictors at this step. So 40% of the variability is accounted for by adding all those predictors. And that is then it's considered a good fit because of the -2 log likelihood. So that score of 32.167 is the goodness of fit statistic. So we want it to be small to show a good fit, and it's suggested if it's less than 100, it's a good fit, and if it's less than 20, it's a very good fit. So we see this as a good fit. So here's what the classification table looks like now that we've added all those predictor variables. And you can see that our overall percentage is now 79.5, which suggests that it's a better fit when we add all those predictor variables. This next box just again explains what all the variables in the equation include. So now let's go back. We're going to close out this output. No, I'm not going to save it. And we're going to go back and do the stepwise analysis. So as you go back, you'll notice that you'll go to Analyze Regression, Binary Logistic, and everything we put in there before is still in there, and that's good. The thing that we're going to do now is change the method. So the enter method puts all those variables in at once. And if we want to do stepwise, we're going to say forward conditional. So click on that and hit OK, and you'll get your logistic regression. And the top part is going to be the same as what we just looked at. You're going to get your your beginning block looking at with none of the variables, and then you're going to move down to block 1, which tells you the method now is forward stepwise and it's conditional. So now the stepwise tells you it's significant. Stepwise takes the single best predictor in the model first, and this is your best predictor in step 1, and you'll notice it is significant, but as you move down in our table here, you'll see this -2 log likelihood ratio is just a little bit higher. So it's not quite as good a fit as when we used all the predictors last time. So next, the classification table suggests that we now have 75% accuracy predicting who will abstain by just adding that one strongest variable, and that's compared to the 68.2 we had with no predictors in the model. This next box tells you the variables used in the equation, and as you can see, they use discharge status, and SPSS determined that was the strongest predictor. And this table also gives you the beta weights for the predictor, and again, as you look at the learning guide, it will remind you that in the logistic regression equation, you can write the equation for this logistic regression curve using that discharge status as a predictor. Next, we see the variables that are not in the equation, and they are listed there for you. So this table tells you that adding discharge status did make a significant difference, and that difference was the 14% or 14 points better prediction using that discharge status. And then SPSS stopped there after this analysis because they found that adding more predictors wouldn't help us get any better fit between this model and the data. You can have stepwise procedures that continue to add more and more variables, and sometimes all of the predictors still get added if they're found to increase the goodness of fit. So I hope this was helpful, walking you through both the inter-analysis, where all variables go into the analysis, and also the stepwise. Have fun playing with the analysis practice assignment, and then go on to do the analysis assignment that you'll hand in for a grade. Do not forget that for the assignment you hand in, you need to actually convert or recode the variables for your homework so that you only have 2 variables for the logistic regression output.